Start this one. They gave me too much mumbo jumbo. Why
Did
is
they?
this order? I don't know. Why is
They, or you could say they gave you lots of mojo.
Actually, you can read it right now. Do you like the new teaching? Today's one cool.
Okay, so we have one here and one here and one here and one here.
The ones on the left are X's.
Okay. So what direction is the magnetic field? From the upper left. Does it rotate clockwise, counterclockwise? Does it go into the board, out of the board? What is it doing?
It's going, yeah, clockwise.
So current's going in, my hand wraps to the right, so it does indeed circle around like this, like so. What about this one? Same thing, so this one sweeps through like that. What about this one? Counter. So it sweeps through like that. And this one sweeps through like that.
We gotta find.
So it looks like I have one here, one here, one here, one here, and those are all focused around the center. Agreed? So I have one that looks like this, one that looks like this, one that looks like this, and one that looks like this. If I pulled them out, you know, I covered everything out. Just looking at that one and that one. So when I sum these magnetic fields, then I should say B1 plus B2 plus B3 plus B4. Agreed?
Yeah.
And how much does this sideways contribute compared to this one?
The sun.
The same amount, because these are on corners of a square. So every one of these has an angle of 45 degrees. In essence, they're all the same contribution, but opposite in direction. So the x's, if we sum the b along the x, that equals 0. But if we sum the b along the y, well, that's pretty important. That's a down, that's a down, that's a down, that's a down. It looks like I have 4 of them going down. Does that make sense so far? Because these are vectors. We're talking vector components. So if I just could figure out the value of this and find the downward portion and multiply by 4, I would have this thing. So how do I find the magnetic field right there? Let's grab this one. How do I find that? I know it's this far away. How far is this far? I should have used
4 meters.
blue. Darn. Well, this is, you could make 2 mistakes here, and you just made 1.
Center of the edge is 0.4, so it's
It's 0.4 meters along the side. Agreed? The square is 0.4
45
meters.
degrees.
So if it's 0.4 from here to here, how far is it from here to there? Half of that, which is 0.2 meters. But that clearly is not this. So how big is R? I'm thinking it's 0.2 squared plus 0.2 squared, take the square root scheme.
Okay.
So it's actually 0.2 times the square root of 2. It's the diagonal of a right triangle. Yes?
Mm-hmm.
And specifically, it is a, what do they call it? Isosceles right triangle? These two sides are congruent. So now we have the actual value of R to be 0.28 meters. Now we can go back to this. By will equal mu I divided by 2 pi R. I have R. Do I know the current, I? It's given to us, right?
Yeah, 5.
So we just plug it in and get our value. So by, oh, I gotta do one other thing. Get your calculator, put cosine of 45 degrees. Because this is the y component, I forgot. This is the y component. How do we find the component along the side of a triangle? We gotta use either sine or cosine, right? And it's a 45, 45, 90 triangle, so I'm gonna use cosine 45.
And then you multiply
And
that.
then I'm gonna do everything by 4. I gotta remember to multiply by 4 because there's 4 contributions.
They're all the
Going
same.
down.
So each one's
They're all the same size, yeah, because it's 5, 5, 5, 5. They're all the same radius. That's one
So you could just
quick approach.
You could just do that equation right there, multiply by
This
4.
equation and multiply by 4. And you should get an answer of 1 times 10 to the negative 5th.
Yeah, I got it.
Yeah! All right.
So it doesn't matter if your calculator's in radians or degrees, because mine works in radians.